This is 4.2, more about graphing rational functions. So in the last lesson, we talked about graphing rational functions, remember, which is a polynomial over polynomial. And the thing I emphasized was about looking for the asymptote. Look at the denominator. The denominator is going to tell you where x cannot be, and that's your vertical asymptote. And then I also talked about the horizontal asymptote and the ways that you can determine that. So here we're going to take it a step further, and we're going to look at, it's going to seem very similar to the last lesson. So here we are, we're going to go straight into it. So here we have a function, and notice the denominator. This could be rewritten if you factor this. Factors to x minus 2, x plus 1. And that should tell you automatically that x cannot be 2 and x cannot be negative 1. So that tells me I have two vertical asymptotes at negative 1 and at 2. And then what you should consider is think of an XY chart, think of the numbers around those numbers. So let's talk about 2 first. So anything bigger than 2, so it could be 3, 4, 5, or even 2.1 or whatever it is. And what's happening to the right of x equals 2. And then think of the numbers, think of another XY chart. Again, just mentally, just think about it. All the numbers to the left of a negative 1. So that would be like negative 2, negative 3, and even really close to negative 1, like negative 1.1, negative 1.2. What is actually happening to the function? And then finally, think of what's happening in between those two numbers, in between negative 1 and 2. So all the numbers in between those, the nice numbers would be 0 and 1, but think of all the numbers in between that, like negative 1/2 and 1/2 and 1.5. Anything in between negative 1 and 2. And without a calculator, you would just plug those numbers into the function and then just get some XY values. You don't have to have a calculator. But with a calculator, just go ahead and plug that in. And we know, again, what x cannot equal. So we're going to graph this and notice that what the function looks like, and we would get values. Let's consider from left to right. So from left, this would get very close. By the way, I didn't mention the horizontal asymptote. So the horizontal asymptote, because this is bigger than the 1, so the denominator exponent is bigger, so the horizontal asymptote's at 0. Okay, so I should have mentioned that first. So there is a horizontal asymptote right at 0. Then you're just going to graph this, and notice as it gets closer and closer, as x gets more negative, negative 10, negative 11, negative 12, it gets closer and closer to 0. And then as x gets closer and closer to negative 1, then it gets bigger negative infinity, but never reaches that. And then look what happens in between there, in between those two vertical asymptotes. So we have, it's like if you plug in x is negative 0.8, 0.9, it's way up here, okay? And then it's going to come down, sort of look like that. And then on the right side, again, if you anything to the right side of 2, it's going to be starting infinity. It's going to get lower and lower and lower. And it's going to start getting so close to that line right there. Okay? So again, without a calculator, you would just plug in. Really, all you need is 2 or 3 numbers, 2 or 3 numbers, 2 or 3 numbers, and plug them in to be able to get your value. With a calculator, you can easily see what the values are, and you could always go to the table and take some numbers off there to make your graph more accurate. All right, let's go to another one. So notice the very first thing you want to do is find the vertical asymptotes and the horizontal asymptotes. Well, notice on this, so I don't forget, let's do the horizontal asymptote first. Notice the x squareds are the same. So that means whenever they're the same, you're going to look at your a divided by your b, which is 1, so y equals 1, which again, that's your horizontal asymptote here. Okay, now let's find our vertical asymptote. Our vertical asymptote, it's all about the denominator. And so if we factor this, so x minus 3 and x plus 1, that tells me x cannot be 3 and x cannot. So at 3 and at -1. All right, and then so you just have to consider what's happening in between those numbers. Something I do want to emphasize, and I've said it a bunch of times, make sure you don't just rely on the calculator. Because if you rely on the calculator only, then if you just push graph, like I plug the function in, I push graph, you're going to graph that, and unfortunately sometimes you got to pay attention to the calculator, because the calculator graph is correct, okay? That is the correct graph, okay? But if you notice this, it says x cannot equal 3. So it can't, but yet I have a vertical asymptote here. Well, what's actually taking place, if you look at this table, x cannot be 3. See, I absolutely know x can't be 3 because it tells you, and x can't be -1. So it literally tells you that right there where it says error. So it can't be those numbers, and when you graph this, if you actually zoomed in to actually equals 3, so let me actually show you what's happening when you have XY chart. So at, I'm just going to look at these numbers here. So at at 0, it's 3. So if I go to 0, 3, it's right there. Even if I look at more decimals, 1, 2, 1, 2, and then 2, and then 5/3. Now, what actually takes place at 3 is, I mean, if you actually look before you got to 3, so consider all the numbers between 2 and 3. So like 2.1, 2.2, 2.3, I mean, all the way until you get to 3. So the graph keeps going closer and closer and closer, but it can't actually equal there. So you're going to have an open circle there. Okay? You're going to actually have an open circle. And when you look at the graph, it doesn't actually show that. Okay? It doesn't actually show that, but you're going to be getting closer and closer and closer to that point right there at x equals, whoops, I went too low. So I forgot about my y asymptote here. So notice this, it doesn't go below that, so it just keeps getting lower and lower and lower. You got to do that. But here, open circle right there, an open circle, because it cannot actually equal when x is 3. When x is 3, this is undefined. So that's an open circle right here. And again, if you look at the graph, it does not show that. So you have to absolutely pay attention that x cannot equal that. And then the same thing over on the left-hand side. So you're going to be graphing that as well. So it's going to look like this. All right, so again, the emphasis at the very beginning, find out your vertical asymptotes, find out your horizontal asymptotes, and then start graphing from there. And then finally, let's talk about one last type of asymptote. We talked about a vertical asymptote, we talked about a horizontal asymptote. There's also a slant asymptote. So when the numerator exponent is 1 more than the denominator exponent, then it creates a diagonal asymptote, a slant asymptote. So here's an example. So notice the numerator. So we have the numerator right here. It's 1 higher than the denominator exponent. So whenever that happens, we have a slant asymptote. Now, something that, before we get busy with the slant asymptote, and I have it graphed over here. You can see, I plug this in, I push graph. You can see what it looks like. But so like, how do you know where that slant asymptote is? Like, how do you know exactly where that line is? Well, first of all, notice that the denominator, something you should notice right off, x cannot be -1. And so that tells me that there's a vertical asymptote right here. All right, and because the exponent is bigger up top, there is no horizontal asymptote, which is good. But notice you have x can't equal -1. And then once you start plugging in numbers that are close to -1, so matter of fact, look at the table, and so like at -2, it's down at -6. It's down here at -2. And then at -3, it's at -6 again. It at the same number. And then all of a sudden, -4, -5, -6, -7, -8. Notice those numbers are getting more and more negative. It's going down like this, so it's going to loop up like this. And you can see that from the graph. Okay? You can see that from the graph. Now, how do I know where the diagonal is? Because, I mean, we could just copy points here. So notice what happens on the other side of -1. So here you have 0, 0, which, I mean, I could graph that. That's an easy point to graph. 1, 0. 2, 2/3. We don't have to graph every single point, but you notice, let's see if I can find a nice one. I'm not going to, so I know it's going to start going up. So even at 6, it's at 6, and then that's 4 and 2/7. So at 6, it's at 4 and 2/7, about right there. So I know it's going to go up like this. And then if you look at the graph, like what happens before that, it just loops back up real quick. That, and the slant, how do you know where the slant is? Well, if you take this problem and you actually divide it, like that's what it says. It says divide it. So if you actually divide it, like using log division, notice I have x, and then don't forget to subtract. Now, what does this mean? Well, if you notice this right here, so that's literally y equals x minus 2 is my slant. So if I literally graph this at -2, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Down 1, down 1, down 1, down 1, down 1, down 1, down 1. So notice my slant is right there. That's the equation of the slant. And you're saying, well, what's the remainder for? Well, the remainder is like, you know, what's left over, you know, as it gets closer and closer to that slant. That's why it's getting that way, is because you have that leftover remainder. It's never going to touch that line. It's always going to be a little bit away from that line. That's what that means. But this right here is the actual line of the slant. So if I ask you what is the slant, you literally just need to use log division to be able to get that. Again, the calculator is going to come in handy, but I showed you ways to do this without the calculator as well, which you can do it without the calculator. It just increases the amount of time. And that's how you graph vertical asymptotes, horizontal asymptotes, and slant asymptotes.